Today we are going to do these things now. We'll continue with wherever we had stopped. Okay. So
Yes, sir.
now look here. Last day, what did we do? We'll quickly go through it because it is just the continuation of that. Clear? Uh, we had done electrolysis of fused lead bromide. Clear? And this fused uh, lead bromide is solid in uh, what is called physical state. So what we'll do, we'll heat it. So the apparatus you have seen here, which is the cathode anode, how the connections are done, all those things you have to know, isn't it? These points: what is electrolyte? Fused lead bromide. What are the particles present? Lead ions and bromide ions. Clear? Then temperature is 380. That is your melting point of lead bromide. This temperature, whatever temperature we take, that is your melting point of lead bromide. Clear? So that I told you last day also, isn't it? The electrodes which we are using is graphite electrodes. Graphite does not react, so it is a inert electrode. Okay. Then the next thing you can see there, uh, the reactions. The reactions, there are always three reactions, isn't it? At cathode, at anode, and dissociation. First, you have to see the dissociation part. In dissociation, what happens? The ions are formed since you have only lead bromide, you have lead ions and bromide ions. So these ions, what is happening? One will go towards cathode, one will go towards anode. Cathode is negative, it will attract the positive one, that is lead ion. Lead is discharged, and therefore you can see silvery white deposits on the cathode. That is, lead metal is deposited. And at anode, bromide ions will go. These bromide ions are negatively charged, so it will give one electron to anode, and then it becomes uh, discharged without any charge, isn't it? So bromine is formed. Bromine is actually a liquid, but at this temperature, it is a vapor state. So bromine vapor means brown fumes you'll see there. So observations are very important. So all these points, learn it. Then we did the next one, that was the electrolysis of acidulated water. Pure water does not conduct electricity, isn't it? So what we do, we add a small amount of sulfuric acid just to increase the electrical conductivity. Yeah. Now what is done after that? uh, we pass electricity. So the electrolyte is acidulated water, particles present. Water will dissociate and sulfuric acid will also dissociate. So you have H plus, OH minus, as well as SO4 2 minus. You can see the dissociation is given there, isn't it? So these are the ions which are formed: hydrogen ions, hydroxyl ions. Again, sulfuric acid is hydrogen ions and sulfate ions. So hydrogen we have written once, OH and SO4. These are the ions which are present. It's already a liquid. We don't have to heat it. That means we carry out at room temperature. The electrodes we are using is platinum. Again, platinum does not react, so it is an inert electrode. And then the reactions, the dissociation, water dissociates and sulfuric acid dissociates. Both are dissociating. These ions will be attracted towards cathode and anode. So at cathode, cathode being negative will attract the positive. Positive is hydrogen only. So hydrogen is discharged. That means you'll see a bubbles of colorless gas. That is, hydrogen is evolved. And how you identify hydrogen? It burns with a blue flame with a pop sound, isn't it? At anode, what will happen? OH minus will go, and this OH minus, what will happen? It will, this OH minus will be discharged at the anode. So OH, there's no compound, so that decomposes. Finally, you get oxygen. So here also you'll see bubbles of a colorless gas, that is oxygen. And oxygen, how can you identify? By putting a burning splinter. It starts burning in a flame. It rekindles, isn't it? What you see here, in both the cases, you can see bubbles, but the bubbles of hydrogen will be coming out faster, and oxygen will be slower, and the amount of gas collected, hydrogen will be twice that of oxygen. So these all we have done, isn't it? So next, what we'll do? The next one was electrolysis of copper sulfate. Now from here, these things, whatever we have done, and this will continue with this only. We are doing electrolysis of copper sulfate, and then we are using platinum electrode. So here, the platinum electrode is a inert electrode. Okay, you can see the electrolyte, that is aqueous solution of copper sulfate, that means copper sulfate and water is there. Particle presence, you can see 4 different particles are there. Copper sulfate, so 2 ions. Water will break up into H plus and OH minus. Temperature is again room temperature, isn't it? The electrode is platinum, that means does not react. Okay, then the reactions, dissociation, these two are dissociating, you can see the dissociation here. Then at cathode, copper is discharged, that means you'll see reddish deposits on the cathode. And then on anode, OH minus goes, because SO4 and OH you have to choose, select, so OH minus goes, and then you get oxygen there. Points to note, we already saw what will happen when we are taking this copper sulfate, that is blue in color, but that is blue color due to the presence of copper ions, isn't it? Those copper ions are discharged. Now once the copper ions are discharged, what will happen? The blue color will slowly fade out, and therefore it will become colorless. That is a very important question that is asked. Another thing, out of the 4 ions, only copper and OH are discharged. That means hydrogen and sulfate ion, they accumulate. When these things are accumulating, what will happen? Sulfuric acid is formed. That means the solution becomes more and more acidic. Okay, so that we did. The pH will decrease and the mass of cathode will increase, whereas anode there's no change. Cathode, something is deposited, so it will increase. Clear? So till here we had done. Now we'll continue from here. We are again doing copper sulfate only, but we'll select a different electrode which can react. Okay, so now we'll take electrolysis. Electrolysis of copper sulfate solution using copper electrodes. Now we're now using copper electrodes, and you know copper can react. So the process, more or less, it is same. Yeah. For this again, we need the diagram. Okay, so this is your uh, diagram. If you take this, then in this case, again, 2 electrodes are there. Now you can see the electrodes are copper electrodes, isn't it? The electrodes are copper electrodes. The electrolyte, everything else is same. The direction of current and all those things also remains the same, isn't it? So what you can see here, positive, that means the current is going this way and it is coming out this way, isn't it? So here again, we'll write down the same things. The very first thing, what you have to know, what is your electrolyte here? We are using the same thing, so electrolyte. What will be the electrolyte? We are again taking copper sulfate solution, so we can take aqueous solution of copper sulfate. Aqueous solution of copper sulfate. That means you have CuSO4, and along with this, water is also there. So two things are there. What particles will be present? particles present. We are doing the same thing what we did last day. Particles copper sulfate will break up into Cu2 plus and SO2 minus. Water will break up into H plus and OH minus. So 4 ions are there. What is the temperature here? Again, it is a liquid itself, so we are carrying it out at room temperature. Okay, the reaction is carried out at room temperature. Then next thing is your electrodes. What are your electrodes now? Cathode and anode. Now here you can see here in the heading only we have written copper electrodes. So that means the cathode is made up of copper and anode is also made up of copper. Now this copper can react. So what can happen? What can happen here? This can react means it is a active electrode. The others were inert. They were having no effect, but this is active means this will take part in the reaction. So it is a active electrode. Now the reactions again. If you take the first one is again dissociation. So dissociation, what will happen? Copper sulfate will dissociate into Cu2 plus and SO2 minus, isn't it? And water will also break up into H plus and OH minus. So you can see these four particles are the ones which are present. The particle present are these four. Hurry up as you complete, let me know. Finished all of you copying?
Yes, sir.
Let's continue now. What we have done is dissociation. Now once this is dissociated, these ions now they'll move towards the cathode and anode, isn't it? So which one will move and how it will move? Let's see that. So the next one, we'll see the reaction at cathode. The second one, reaction at cathode. Cathode is negative, isn't it? So it will attract which one? Positive. So what are your positive ones? We have Cu2 plus and H plus. So both of them will go there, isn't it? So here what is coming in? Cu2 plus and H plus. So again, two things are there. They'll compete with each other, and when they compete, which one is given out? The one which is present lower in the series, isn't it? So your series is this. You can see here what is there? Copper and hydrogen. Hydrogen is above and copper is just below it. So what will happen? Copper being lower, it will be discharged, isn't it? So since copper is at a lower position, copper will be discharged. So copper is discharged and H plus is not. Clear? So what happens here? Cu2 plus, this coming from the solution, it will take two electrons and then This will form Cu. This one is copper metal, so reddish deposits on the cathode of copper metal. So copper metal is deposited. So what we saw in the previous case, it is exactly the same, isn't it? It's exactly the same. Okay. If you see here, the only thing I'll explain it a little more here, that is Cu2 plus. This is coming from solution. Cu2 plus, where is it coming from? From the solution. Two electrons, where are they coming from? From cathode. Okay, these are coming from cathode, and this, once it combines, it forms a neutral one, that is this one, isn't it? So this was similar to what we had done before. Now the next one, reaction at anode. Anode is positive, so since it is positive, it will attract the negative one. Now the negative one, what is the negative one? Sulfate ion and hydroxyl ion. So these two are the ones which are going there, isn't it? So what is coming here? SO42 minus and OH minus. These two are there. But again, here there has to be a loss of electron. The ions will lose electron, isn't it? So in losing electron, the copper metal, that is the electrode itself, is also there. So what will happen here? SO4 and OH minus, they have to lose electron, but they are not what is called non-metals. For them, losing electrons are difficult, but copper being a metal have a great tendency of losing electron, isn't it? So copper being a metal has a higher tendency to lose electron. It has a higher tendency to lose electron, means to get oxidized. Clear? So what will happen here? SO4 will not be discharged. OH minus ion will also not be discharged. What will be discharged is copper. So basically what is happening here? Cu, this is from anode. This copper is from anode, isn't it? It loses two electrons. Okay, this electron, where are they going? Is going to anode. It is given to anode. And what will happen? This will form Cu2 plus. So Cu2 plus means it's a copper ion. Therefore, this copper ion, what happened? This goes into solution. So this copper ion goes into solution. So you can see the last part is different. In the previous one, the metal on the electrode had no effect, but here the metal is active and therefore it can react. Since it can react, the reaction is different. Clear? Copper ions are blue in color, so that blue colored ions are going into solutions. In the second part, you can see in the first part the blue color of copper ions are discharged. In the second part, the blue color of the ions are formed. So we'll see what changes it makes. Have you all copied? Then let me know. Hurry up.
Yes,
So you can see the reactions now. Now from these reactions, there are few changes. So we'll see those changes, what changes are there. So we'll write down the points to note here again. Now this is for copper electrode one. Clear? So write down points to note. Now here if we'll take the same point, the first one, copper electrode. Copper is the, what is called, blue in color. So that blue color, what happens? Let's see, isn't it? So what will happen? Let's see. Copper ions, Cu2 plus ions are discharged at the cathode. Copper ions are discharged at the cathode. That means the number of ions should decrease, isn't it? But at the same time, Cu2 plus ions are formed at the anode. So at cathode, it is being removed. At anode, it is being formed. So what will happen? As a result, at cathode, it should decrease. At anode, it should increase. So since they are in the same solution, the total number of ions in the solution remains same. Clear? So hence, the total number of Cu2 plus ions in the solution remains same. Blue color of the solution remains same. As the number of ions are same, the blue color will also remain same. Okay, so the blue color of the solution remains unaffected. That means it is remaining the same. It was blue and it will still remain blue in color. Then the second one now, number two. We have already seen what will happen. Copper, Cu metal is deposited at the cathode. Cu metal is deposited at the cathode. So the mass of cathode increases. Copper metal is deposited, so the mass of the cathode will increase. But what will happen? What will happen at the other end? but Cu2 plus ions are released from the anode. So the mass of anode decreases. So you'll see that the anode will become thinner and thinner, the cathode will become thicker and thicker. Then the next thing, number 3, if I take this process, cathode is becoming bigger, anode is becoming smaller just by depositing of copper ions. So this we can utilize it to purify copper, because the ions which are moving is only copper, isn't it? So you can write down this process can be used in purification of copper metal. Purification of copper metal, and is called electro refining. So electro refining means we are going to purify metals. Have you all finished?
Yes, sir.
Yes. Okay. So the electrolysis part, the different process of electrolysis, we have already completed. You don't have to do any more electrolysis now. Clear? You can do any electrolysis. Apart from this, you can do electrolysis of different things. But in all the cases, your process will be same. Okay. In all the cases, your process will be same. Cathode, anode, first dissociation, then cathode and anode. So these things will be followed, isn't it? Now, this electrolysis, what are the applications of electrolysis that you have to know? So the next part we'll see is applications or uses of electrolysis. Applications of electrolysis means this electrolysis, where are we going to use it? So to use it, basically we'll study three main process. The first process, I'll just give you an idea of the process, then we'll see the details of each process. The first one is electroplating. Electroplating, the name itself says we are plating something, means on one metal we coat another metal. Okay, so just the basic idea is coating of one metal over the surface of another metal. One metal is coated with another metal. How it is done, we'll see after this only. We'll just classify them and then we'll see how these things are done. That was the first process. The second process, number 2, is the one which I told you just now, that is electro refining. Electrorefining means it is a process of purification of metals. These are just an idea. These are not the definitions. And the third one, number three, that is electrometallurgy. Electrometallurgy deals with the extraction of metals. Metals are not found in pure state, isn't it? So compounds and other things, minerals are found. So that we convert it into pure state. That process is called metallurgy. So process of extraction, process of extraction of metals. Finished copying, all of you?
Yes, sir.
Yes, sir.
We'll continue. This three of them, we'll see them in details now. Clear? So one by one, let's see. The first one is electroplating. Now what is electroplating, that you have to know. Clear? We have already said we coat one metal over another. But when we coat one metal over another, then in that case, can we coat anything over any other metal? No. For that, we have a certain restriction there. Okay. Usually what we do, uh, better metal, that means a superior metal is coated over an inferior metal. It cannot be the other way. Like for example, if I take iron, I can coat iron with gold or silver because they all are superior than iron. But I won't take a spoon made up of silver and coat it with iron. That we never do, isn't it? So what we do, we always coat a superior metal over an inferior metal. So a superior metal is coated over an inferior metal. Clear? And that process we use electrolysis. Okay. So write down the definition first. Electroplating is a process of coating a thin film. A very thin layer is put. A thin film of a superior metal on the surface of an inferior metal. We are coating it using the process of electrolysis. We are using electrolysis and then we are coating one metal with another. Okay. For example, what I can do, uh, for example, I could have taken iron spoon can be coated with silver, but the reverse will not be true, isn't it? I could have taken silver jewelry. Silver jewelry can be coated with gold. This we can do, but gold we won't coat it with silver. So this way you can easily identify which is superior and which is inferior. If I ask you why do we electroplate, what is the reasons behind it? What are the reasons for electroplating? Why do we electroplate? Basically, that is your question. What are the basic things which we want to prevent? The very first thing, electroplate, so that we can prevent rusting of iron. Iron, can rust. So if it is coated with a better metal, that won't rust, isn't it? Or, in other words, I can say in a broader term, I can say to prevent corrosion, isn't it? So the first reason here is to prevent rusting of iron, or I could have said corrosion in metals. If you want to stop this, then we do electroplating. And the second reason, what can it be? Why do we electroplate? The second reason is we want it to look better. The appearance will make it better, isn't it? An iron spoon looks dull, but if it is coated with silver or gold, the appearance is much better. Then the demand will also increase, isn't it? So, whatever article we have, we can enhance the appearance, isn't it? So, the second thing can be to enhance the appearance of the article. To enhance the appearance of the article. Okay, now the next thing is, how do we electroplate? This you have already done, isn't it? So I'll change the page. You all are finished? Hurry up.
Yes, sir. Yes, sir.
Okay. So now we'll take the process, how it is done. Okay. So let's talk about the process of electroplating. You know, on the metal, uh, on the article, you can say the other metal has to be deposited. And you have just seen in electrolysis, where are the metals deposited? The metals are deposited at the cathode. That means the article which we are going to coat should be made into the cathode. The cathode itself will be the article. Clear? So the first point you write down, number one, The cathode is made up of the article on which coating is to be done. If it is an iron spoon, then that iron spoon itself will be the cathode. Then the second one, remember, on this we are coating a metal. We need a regular supply of that metal. So the anode should be made into the metal itself with which we are going to coat. The anode is made up of block of the metal, block of the metal with which coating is to be done. So whatever we are going to coat, that will form the anode. A block of the metal will be that anode. Suppose I am going to coat silver, that means the anode will be made up of a block of silver. The third one, number 3, we have done cathode anode. Now the thing is electrolyte. You know, in electrolytes the ion has to move. So which ion should be present? Yeah. So write down the electrolyte must contain the ions of the metal, ions of the metal with which coating is done. So cathode anode electrolyte we have already done. Now number 4, you know, there are two different types of electricity. You have current. If you take, then there can be direct current or it can be alternate current. So here in electrolysis we always use direct current. So always direct current, always direct current, that is DC, is used. We never use AC, we always use DC. Then number 5, when we are going to coat, then what we need a uniform coating all over. So for that, what we do, we always pass a small amount of current for a long time so that slowly the coating is done uniform. If I pass a large current, then the coating can be done in lesser time. but the coating will not be even. Uniformity will not be there. Clear? So what we do? We always pass a small current for a longer time. Okay? So you can write down there. mm, A small current is passed for a long time. A small current is passed for a long time for uniform coating. We need uniformity there. So we always pass a small current and for a long time. So slowly it is done so that things are uniform. Okay. And then number 6, when we are taking this, then in this case, the surface of the article, whatever article we are going to take, we are coating the metal, so the metal has to stick to it. That means the surface should be clean and it should be made free from dust, oil, grease. This thing should not be present, otherwise the coating cannot stick there, isn't it? So the surface of the article to be coated should be clean and free from dust, oil, grease, etc. So these things should not be there on the surface. Have you all done?
Yes, sir.
Now look here. We'll carry out the reactions and the reactions will be same as the one which we saw in electrolysis of copper sulfate using copper electrode, because the electrode here is active. Okay, so what you can write down, basically what will happen, what you have written up till now is this. Look here, if I give you the electroplating, then you have a container, and in that container what you are going to take, the electrolyte, isn't it? You have cathode and anode, isn't it? So let's take an example and then we'll see this. So example, we can take electroplating of an iron spoon, electroplating of an iron spoon with silver. So basically what we have a article as iron spoon. So here I'll take the spoon itself. You know, you can draw better diagrams, better than me at least, isn't it? This is a spoon and the spoon will be connected to the negative end. Clear? So cathode. What is the cathode made up of? The article itself. That is iron. And then we'll take the anode. So anode is a block. So we have taken a block of the metal, and this will be anode. This is a positive end. What is it made up of? Block of metal with which coating is done. What you are going to coat with? Silver. So block of silver I'll take. A block of silver. Then this I'll fill it with an electrolyte. This whole thing will fill it up. What will be the electrolyte? And this electrolyte, what should it contain? Must contain the iron of the metal with which coating is done. So coating is done with silver, so must contain silver ions. That means Ag plus ions should be there. Okay, where do you get this from? This is obtained from a solution of this NaAgCN2. This one is sodium. Ag is silver, you can write down, or Argento you can write down. So I'll write down silver and cyanide. Sodium silver cyanide solution we are taking. And this is the one which gives you silver ions. Okay, look here. I'll just summarize all those things, whatever we had taken. I'll just summarize it in words. Clear? What we were using is electroplating of iron spoon with silver. What was your cathode? Cathode is made up of the iron spoon itself. The iron spoon itself will form the cathode. Then anode, what we are taking as anode is made up of a block of silver ions. This is made up of a block of not silver ion, silver metal. Block of silver metal. Then electrolyte. What should it be? Must contain Electrolyte must contain Ag plus ions, isn't it? And for this, we use sodium silver cyanide solution. Clear? And then finally, I told you the reactions. What will happen at cathode? Things are deposited, isn't it? So what happens is Ag plus, this from the solution will take a electron and form Ag, that is deposited on the spoon. And at anode, it's just the reverse. You can write down Ag minus electron gives you Ag plus. That means silver from the anode loses an electron and goes into the solution. So these all points you have to learn. Any problem, all of you? Anyone, any problem? No. Then today's class will end up here only. Okay. Today's class will end up here. Go through the things which I have taught you. One more class and this chapter will be completed. Finished, all of you? Copying? If you have finished copying, then you may leave. Thank you, all of you.
Thank you, sir.
Thank you, sir.
Thank you, sir.